couldn't find people with an accent when they're producing the CD. So let me just show you.
Although honeycombing loss occurs with block stacking, it does not pose a problem when we have high turnover of a limited number of items.
Again, engineer's perspective, honeycombing.
Is block stacking usually the most effective way to use the available space?
And now if you click on the professor, she's going to say something else.
It's not very efficient.
Okay, I'll let you explore that on your own, but if you notice there was a sort of a talking head at the bottom that disappeared. Once you listen to all the voiceovers, that goes away. You can go back and play it any number of times that you want, but that's one feature that we have.
In storage areas, click on the buttons for the engineer. Why does click on the pic?
Oh,
click on the
let me
picture,
back up
click
for a
on the
second.
picture to watch the remove. Why does it take time to get to the targeted material? When should the stationary storage rack be more efficient?
So when you're working with these cognitive psychologists, they say that every time you introduce a concept, go back and ask them questions about it so that they can reinforce their learning. And so you'll see some of that actually show up at the end of each layer. So what we do in this explore layer is, now that they've seen all the key aspects of the principle, please go back and say
the removal of the highlighted item.
They can go back and see the same video or animation and then again answer questions. So before they saw it without really knowing much about anything, now that they've seen the key aspects, what are, has their answer changed, kind of thing. The third, okay, this is the explore layer. And we've designed the CD so that if there is a voiceover, well, until you've finished hearing the voiceover, you cannot do anything else on that screen. You can go to the next screen if you want, but if you want to do anything else on that screen, you've got to wait until the voiceover is over, so that way you're kind of forced to listen to the person there. But, Keith-John talked about the Q per order index policy. Well, this is what, for lack of a better name, we called it a play space, which is an area where you can actually create your own problem within some limits. And it'll tell you what the best solution is for that problem, the optimal solution. But then it'll come up with a random solution of its own and then encourage the student to actually get to the best solution without telling them anything about the Q per order index policy in this case. So our idea was that, let's let the student explore on their own why making certain moves leads me to a better solution and why some others don't. And so in this case, again, we have 4 products. Click and drag the slider to change the numbers, or just go into the box and text input the information directly. I'm going to change this to a 5. The only restriction here is that we need to have a total of 16 spaces occupied. So when okay, now it is 16. The cost is, what is the unit load, unit distance cost to move product A versus product B versus C and D. In this case, I kept them all the same, but if you want, you can change that. Frequency is, how many times does the product go in and out. And like we saw earlier, I guess the best, now that we know about the Q per order index policy, the best, the product that needs to go to the port, the input-output point, would be the one that has the highest frequency, ratio of highest frequency divided by space occupied. So for the product A, it is 20. Product B, it is 80 divided by 3. That's what, 20 something, 60, and the last one is what is it? 15. Okay, so when you click on the next screen, again, the students have lots of instructions on each screen. So it came up with a random solution of that has a cost of $11.71, but it also tells me the optimal solution is $9.50. And without telling the students anything about the COI policy, I just tell them, move the boxes around and get me to the optimal solution. So they start moving product B here. The cost increases, cost decreases, so that's good. And then let me move product D away and see what happens. Okay, I think that's also helping. So then they're encouraged. So the input-output point is right here at the bottom. Product D, again, let me try to get it out as far away from the input-output point as possible. That helps. How about bringing this product, well, here? That also helped, right? How about bringing it here? That's even better. Okay, and then pretty soon you should hit the optimal solution. There you go. So they get a little bit of a kick by getting, even if it's by trial and error. If they get to the optimal solution, they feel happy about it. But that's, again, there's more talking heads. But then I get into a mathematical model that talks about...
Click on the button labeled Next to see the mathematical treatment.
Okay, so then I talk about the mathematical models here, listing all the assumptions that are made. Okay, where it is? There it is. So it's a lot easier to come to the mathematical model through this play space than directly going to it. They see a purpose in the model and so on. So that you'll see every principle has at least one play space. And this is a CD that has really tons and tons of information, not just the different types of equipment, but also, and maybe it's a good segue into the planning principle, which talks, where is it? Right at the top. Okay, the planning principle, where I'm going to take you straight to the contrast layer. And this is something that...
Discover the principle in contrast in
So this is something that Dick had suggested that I include. What are the consequences of applying a principle improperly? And what are the benefits of applying correctly? So every principle has good and a bad example. And for planning, I think we have the Denver Airport baggage handling system fiasco. And compare that with, Vanderland Industries has actually built many baggage handling systems throughout the world. But the one that I have is from the Oslo airport. So there are lots of cases coming.
Case that illustrates the improper use of the planning principle. In 1989, Denver...
So I'm going to, in the interest of time, I'm going to move through this a little bit faster. But here you have a story that is being told with pictures. And there's also charts and things like that will come up. And at the end, we ask the student, okay, so you can click on this, and this summarizes what occurred with the planning and the execution of the Denver International Airport. And let me click on this one more time. So this camera icon means that it's a picture that you can click on, a graphic that will show up. And again, this tells you what they had planned and what actually happened in early 1995. So it was delayed by about 18 months or more. And I think Jim remembers this very well, right? Happened. Right. I think it was BAE Systems that had a good technology, but really did not do a simulation. Lots of different problems, but this goes through all of that. There were like 2,000 changes from the time they signed the contract until it was completed, until the work was completed. Also, they gave BAE the contract, although they did not bid initially. They made them, forced them to put a bid, and then they gave it to them. Did not do a simulation. They had grand plans. In fact, United came to Denver because DIA had promised them transferring bags within 12 minutes, I think, from one plane to the other. And you were able to check at any kiosk for any plane, and your bag would get there without fail. Percent of bags handled automatically was 100%, but in 1995 it was hardly 12%. Look at the speeds. They were planning on 450 feet per minute, even the ones that were automated and working, but the actual speed was more like 200 feet per minute. So there's that case described.
What went wrong with the plan? The schedule was not related.
Okay, and then some explanation on what went wrong. And it's playing off of an external CD, so it's taking a little bit of time. But again, there's a lot of information about that, plus some questions that the student asks and some answers that the professor gives. And then we get to the proper application where this was done really nicely. And I've been to this airport. It's not that big an airport. It's very small. But still, when I got out of my plane, went to customs, and I was in the baggage belt area, my bag was already waiting there. So, in fact, I was going to give a talk at the ICE Conference on Engineering Education about the CD. So I wanted to really test the baggage handling system, and it worked exactly like how it was written up. The bag was there before I got there. But the problem was that the train station was in the basement, and I had 2 large bags, and I really needed a cart to take them away, but the carts were all sitting in the parking lot, and the unionized workforce that was supposed to bring it back was on a break, and still took me longer for me to get my bags out, but at least the bags were on the belt as promised. So this was so this is an example, but so that's a third layer, right? So you talked about discover, where you discover that there is such a thing called planning principle. Explore, you look at the key aspects, the key principles. Then contrast is where you actually look at a good application and a bad application. And then we have something called extend. And extend is where we extend the planning principle in non-material handling domains. So in this case, we have again another, this is a
Planning to attain goals. Planning is important in managing.
This is a financial planning tool, and students get a kick out of using this. I tell them use this to your heart's content, but don't sue me if your planning doesn't come out the way this model predicts. So this is a simple financial planning tool. Put in your current age, your preferred retirement age, and when I say what is it, people say 45. All my students say, yeah, I want to retire by 45. Okay, so what salary? Sorry? Yeah, I know. What salary do you have now? What percentage of your salary do you expect do you want to have at retirement? Inflation rate, and so you can actually plug those numbers in, and so monthly salary, let me put in, I don't know, how much do students make when they graduate? Maybe 50,000? Let me put in about 5,000 per month. So what percentage of your, let me change the retirement age to 50. What percentage of current monthly salary would you need at retirement? I would say it's close to 80 or even 100 maybe, with healthcare costs and all that. How much savings do you have now? Pension, how much do you expect to get out of Social Security? If you follow the debate that's going on now, probably 0. You have anything in IRAs? Anticipated inflation. So let's do the last 10 years average of what, 3.5 or so. How much is your salary increase that you expect? Then you hit compute. It tells, yeah, it tells you that you, yeah, I can't do that, right? Current age, right? You're starting at, yeah, not a bad deal, right? Okay, so this is how much you need to set aside monthly. More than what you're making, right? So then they go back and say, oh, okay, so maybe I can't retire at 50. How about, yeah, right.
Well, that's kind of depressing.
Oh, this went.
So the longer you wait to retire, the more you kind of put aside.
No, this doesn't make sense. Oh, well, there are no bugs in the CD, by the way. It's been out there, so although it's making sense to you, Jim. Oh yeah, there you go. Yeah. 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 Right. So
Hey, this is real live.
yeah, especially in the academic world, right?
There's no point in saving.
Live for today.